Properties of exponents. Dividing like bases. Like bases simply means that the same variable or number or expression is being raised to a power. If no power is written, it is understood to be the first power, so it's understood to be a 1. For example, this right here, this x with this little m, that's raised or superscripted here, we read that x to the m or x to the m power. All right? So x is the base, m is the power or the exponent. When we divide like bases, we subtract the exponents. Now here's the rule that you're going to see in just about every math book out there. All right? X to the m divided by x to the n is equal to x to the m minus n. So the way the book I teach out of now does it, and in fact every book I can remember does it, they subtract the top, the numerator, minus the denominator, and if they get a negative exponent, then they worry about negative exponents and move it. If you watch my negative exponents video, you'll see that I'd like to get rid of negative first. So I think about this a little differently. Those books also then talk about what if the powers are the same? How do we deal with it? What if the power is bigger than the bottom, the denominator, how do we deal with it? I actually deal with all those scenarios, whether the power is bigger than the top, middle, or top, the bottom are the same. I deal with all that here in this video and the way I think about it. So let's look at an example of what's going on and how we arrive at this property. Now, again, I'm not proving anything to you. I'm giving you an example. So I'm going to work it the way I think about it, and then I'm going to work it with the property, and we get the same answer. And that's just an example. I'm not proving anything to you. But then I'm going to work with the way I'm thinking about it, all the scenarios. First one's going to be x to the fifth over x squared, which is highest power is in the top of the numerator. So what does x to the fifth mean? Well, it means x times x times x times x, right? It means 5x's multiplied together here, okay? And then likewise, x squared means what? X times x. So what I'm going to do is, this leads us to the following. I'm going to take x to the fifth and put this stuff here, right? X squared, put this stuff here, all right? So 5x's over 2x's, and then 2 of our x's divide out. 2 of our x's divide out, and that leaves us with x times x times x in the numerator. And there's no over 1 because it's not a fraction anymore. The 1's in the denominator, so then it equals x cubed. So to apply the property in this scenario, here's what I ask myself. When I'm looking at this thing here, I say, how many x's remain and where are they? Well, 5 is bigger than 2, right? So that means where they remain are going to be in the top, the numerator. How many are left? 5 minus 2 is 3. So let's look at that here. 5 minus 2 is 3, and then x cubed remains in the numerator because 5 is larger than 2. That's the important stuff there that I circled and underlined there. Another way to ask it, where is the biggest power? In the numerator, in the top. So x cubed is left over in the numerator or the top. If you recall the property, x to the m over x to the n says subtract m minus n. This is like my m, 5 is my m, and 2 is my n in that property, okay? So then that's going to give us x to the 5 minus 2. 5 minus 2 is 3, so x to the third. So look, x to the third equals x to the third. We get the same thing. I didn't prove anything. I just gave to you an example of it working. Up here, I thought about it with all these, x times x business. And then at the bottom there, I used the property. So now we arrive at the same result. Okay, here, this x to the third. All right. Let us also look at the following scenarios as well using the same thought process, right? I told you I like ways that always work. I'm going to think about this the same way. Well, look, if I have x to the fourth over x to the fourth, if I start there, that means x times x times x times x 4 times, right? So then same thing down here. X to the fourth is 4x's over here, right? Well, then each pair of x's divides out. And if everything divides out, see, it doesn't cancel. Everything divides out, then all these become 1s, and all these down here become 1s, right? And if I multiply a bunch of 1s in the top, I get a 1. In the bottom, I get a 1. And 1 over 1 simplifies to 1. If everything divides out, you're left with 1. That's why I don't use the word cancel. That's why actually no book in my office less than 30 years old says cancel, because it doesn't. See, we math teachers, we lied to the dictionary and to everybody so long, they used to even in the dictionary. Dividing out like common factors is in the dictionary as cancel, but it's not really what it is. Okay, but that's what your teacher was taught and my teacher was taught, and we just say it sometimes. All right, so I try not to. So to apply the property in this scenario, I ask myself, how many x's remain and where? Well, 4 minus 4 is 0, so guess what? There's no x's left. That's where I get the 1 from. And look, it doesn't matter where because there aren't any. I still ask myself the same questions. How many x's are left and where? 4 minus 4 is 0? None. None are left. So then here, what about if x to the 5th is in the bottom and x to the 3rd is in the top? Now the highest power is in the bottom. So I got 5 x's down here and 3 up here. Now when I cross my x's out, I have 2 x's left, but they're where? They're in the denominator in the bottom, and that gives me 1 over x squared, okay? The x squared is in the denominator. If I divide everything out in the top in the numerator, there's a 1 left, okay? So again, I ask myself, how many x's remain and where? Well, 5 minus 3 is 2. That's the first thing. There's 2 left. And the x squared, that means it's x squared. That x squared remains in the denominator or the bottom because 5 is bigger than 3. And 5 started in the bottom. So I always ask myself where the bigger power of x is and go from there. All right. So here again, or where is the biggest power? In the denominator, so it's left over. Here, if I ask where the biggest power is here, it's the same, right? There's not really a biggest power in the top or the bottom. It's in both places. So that's why there's no x's left over there. There are actual properties that deal with both scenarios above, but we can address those without knowing those specific properties, just thinking through it this way. All right. However, if you want to learn more about those scenarios, then I have properties of exponents 0 power. That's this one up here. 4 minus 4 is 0. And then negative exponents 3 minus 5 is negative 2. And that's one of the other properties of exponents videos as well. All right. So now let's do some of these. Let's actually work some of these things and say, okay, m to the 6th over m to the 4th. What's the question I ask myself? How many m's are there left over and where are they? How many remain and where are they? Well, 6 is bigger than 4, so I no longer have a fraction. I know it's going to be m and it's going to be 6 minus 4 because I subtract. Okay? And I'm going to put it m to the 6 minus 4. I don't put it over 1. There's no fraction left. We don't write over 1 in final answers. And then that's going to be m squared. And I know a lot of you are saying to yourself, I know what 6 minus 4 is. I've said it before. I'll say it again. When you're in a test, right? You may, at your table at home, working on in the desk at school, whatever, you may can get it right every time. But when we get on a test, sometimes some of us are more nervous than others, and I'm one of those. I'm a nervous test taker, okay? And so my mind doesn't work the same way, and I had to recognize that a long time ago as a student, sitting where a lot of y'all are sitting. I had to think about what on earth can I do to fix this problem because I was making mistakes on tests, and I knew better. But it was because I was trying to skip steps. I was trying to do things in my head that I didn't need to do in my head, all right? So then I said, you know what? I better show it. Look, at least if you write this down and then tell them m to the 3rd, then your teacher goes, well, they knew what to do. They just don't know what 6 minus 4 is. Okay? And that's kind of funny, but us teachers, we know, hey, that's because they got a little nervous on the test. Okay? So m squared. And then over here, this one's c to the 17th over c to the 4th. How many c's are left over and where? Well, 17 is bigger than 4, so c to the 17 minus 4. No fraction left anymore. What is 17 minus 4? 13, so that's c to the 13th power. All right. And then what about x to the 8 over x? Where's the biggest power? Well, 8's bigger than, this is understood to be 1, isn't it? We don't write the 1, but you got to know it's a 1. So this is x to the 8 minus 1, which is x to the 7th power. All right. And I wanted to have one of those in there for sure so you knew that was a 1 and knew what to do. Okay. 8 minus 1 is x to the 7th. And then y to the 19th over y to the 14th. Where's the bigger power? 19. So the y's are left over in the top, the numerator. So on all 4 of these on this page, there are no fractions remaining after we simplify these. And it's because they're like bases. These are both x. These are both m. These are both c. These are both y. They're like bases. Okay? Within the same problem, they have to be the same base or you can't do this. And it has to be a single term. You can't do this if it was y to the 19th plus 1 over y to the 14th. You couldn't do this. It has to be one term. So here, y to the 19 minus 14 is y to the 5th, right? 19 minus 14 is 5. All right, let's keep looking at these. Let's keep looking at these. The more examples we see, the better. P to the 6 over P to the 6. Wait a minute. Where's the bigger power of P? It's the same, right? We said that if there's 6 minus 6 is 0, there's not any left over. The answer's not 0. There's no p's left over. If you remember, we divided all 4 of those x's out. So here, we divide out all 6 of the p's, and we're left with just 1. If the power's the same, there are no p's left over, right? There's no p's. 6 minus 6 is 0. None left over. So then keep going here with this one. 30x to the 12th over 10x to the 4th. All right, here I have how many terms right here? I have one term over one term. Okay? Now we get confused with our terminology, not to make a pun on words there, right? But this 30 is a factor and x to the 12th is a factor. That's two factors but one term. 10 and x to the 4th, those are two factors but one term. So here, when you have one term over one term, if you have something, a single term over a single term, you can divide out like factors or factors that are have something in common, I should say. They may not be common, fully common, but things in common. So like 30 and 10. What do 30 and 10 have in common? 10. 10 goes into 30 3 times and 10 once. So I can rewrite this as 3 over 1. Now, I would never write the 1 there in the denominator, but just for emphasis sake, I'm going to keep up with it. I'm going to put it in parentheses. I'm multiplying. It's not necessarily necessary here, but I'm just going to keep up with it. And then how many x's remain and where? Well, if I look at this, x's are in opposite places, so I subtract. 12 is bigger, so my x's are left over in the top, so it's x to the 12 minus 4. So the parentheses are extra here. The 1 in the bottom is extra. Because really, if nothing else is left over in the denominator at the bottom, then there's a 1, and we don't write it. So really, this answer is what? 3x to the 8th. Okay? But I'm trying to show you here where my thought processes are headed by dividing the 30 over 10, getting 3 over 1, then I get 12, x to the 12 minus 4, which gives me x to the 8th. All right, so let's look at the next one with w's in it here. W to the 3rd over W to the 7th. Again, just W over W. How many W's are left over and where are they? Well, there's more in the bottom, 7. So that means my W's are left over down here. W to the 7 minus 3, but that's in the bottom of the fraction. So my 3's a little too big. Let me fix it. I don't like that. I don't want you to think that's, W to the 7th minus 3 like that. That's not what that was. 7 minus 3 is the exponent. So I just did something there to show you this. I just erased it. But as you write things down on your test, be very precise on raising powers and making sure that your teacher knows when they're grading it what you're doing. Okay, that's that attention to detail piece. All right, I've said it a bunch of times. I'll say it again. There's 3 things I want you to do when you do math. I want you to pay attention to detail. I want you to be a problem solver, not a problem creator. And I want you to be efficient. If you can do those 3 things, you will be better at life. And you say, what about life? Everything about life. If you can pay attention to detail, be efficient, be a problem solver, not a problem creator, you will be a positive influence on society wherever you're at, wherever job you do, whatever you do. Even if you don't ever solve an equation or deal with exponents. You will be better at everything in life you do. Baseball, manager of Walmart, working at Burger King as a summer job or job after school, whatever, it doesn't matter. 1 over W to the 4th. 7 minus 3 is 4. All right? So then 15x to the 6th over 5x to the 14th. Again, we have one term over one term. So then we look at the factors. 15 over 5. That becomes 3 and 1, just like I was started the last one, right? Now, x's. X to the 6th over x to the 14th. Where are there more x's? In the bottom, the denominator down here. So that means the x's are going to be left over down here, and it's going to be what? 14 minus 6. And put it in parentheses there. Okay? So that's going to then give me, that's a terrible equals, 3 in the numerator up top, and then 1 times x to a power. I don't need the 1. It's just x to the what? X to the 8th. So 3 over x to the 8th power there. 3 over x to the 8th power. So the other one was 3x to the 8th. This is 3 over x to the 8th. So let's look at some more of these. So again, we have this one right here, negative 45x to the 20th, 15x to the 8th over that, right? One term over one term. And when we have one term over one term, we can take the factors that have something in common possibly. So 45 over... negative 45 over 15. So if I divide that out, does 15 go into 45? Yep, 3 times, right? So this becomes negative 3 over 1. And we'll talk more about the negative sign in a minute, but you can bring it out front if you want to. So here, because you have one term over one term, you can do that. X's, where are the more x's? Up top in the numerator, right? So that means we're going to have x's left over up here. It's going to be x to the 20 minus 8. Nope. Big parenthesis. Okay? So that leaves me, look, if there's only a 1 in the bottom of the denominator, guess what? I don't have a fraction anymore. This is just going to be negative 3x to the 12, right? Because 20 minus 8 is 12. So negative 3x to the 12th. So continuing my theme of going across and using the same color on 2 of them in a row here, we'll say 25y to the 13th, that's 1 term, over negative 75y to the 9th, 1 term. So take these 2 here, we end up with, does 25 go into 75? Yep, 3 times. So we got a 1. I didn't mean for all these to be 3s, but they don't have to be 3. Okay, I know I've done like 4 or 5 in a row that 3 was the common thing. It can be whatever. All right, 1 over negative 3, and then the y's are left over in the numerator. The top, 13 is bigger than 9. It's going to be y to the 13 minus 9. And y to the 13 minus 9 is y to the 4th. And I don't need the 1 because 1 times y to the 4th is y to the 4th over negative 3. It's possible you're able to leave the answer this way. I'm going to clean it up a little bit. If we have 1 term over 1 term, really this is the whole term. If we have 1 term over 1 term, we typically in math, we bring that negative in front of the entire fraction. All right? There are certain classes, if you were in one of my pre-college algebra classes, I'd probably keep credit there. Once you get to college algebra, I kind of want you, hey, let's move that out, okay? Let's move that negative out front. If it's 1 term over 1 term. You can't do that if it's multiple terms involved, then there's all kind of stuff that you would have to think about, all right? But in this case, 1 term over 1 term, we can simply bring that negative out front. So on the next one, again, I have 1 term over 1 term. So if I look at my factors, can 8 and 5 simplify? Nope. So guess what? Bring 8 and 5 out here. Okay? And then m to the 17th is bigger, right? 17 is bigger, so m to the 17 minus 11 in the top, or the numerator. So that gives me 8m, 17 minus 11 is 6 over 5, and I can't do anything else with that, so that is my final answer there. All right? And so as we look at the last one on this screen here, then look at this. That's still 1 term over 1 term. No different. It's just a little bigger. It's got coefficients, the 20 and the 2. It's got the x's, and it's also got the y's. So now let's take 20 over 2. Does 2 go into 20? Yep. 10 times. So if you want to, I can write the 1 like I've been doing there. 1 down there. Typically, I don't. Sometimes I don't write the 1, but I'm writing it for emphasis right now that 2 became a 1. What about x's? There's more x's in the top, right? So it's going to be x to the 8 minus 2 in the numerator. And then y's, same thing. 14 minus 1 of them, right? Minus 1 of them. 14 minus 1 here. 14 is bigger in the top. So there's nothing in the bottom but a 1 left. So do I have a fraction anymore? Nope. No more fractions. So this is going to be 10 y to the 6th over y. I mean, not over, but times what? Not y. I said it wrong. I'm sorry. 10x to the 6th, and then y to the what? 13th. 10x to the 6th, and y to the 13th. All right, let's keep working these. Keep working some of these. All right, got 4 more here I want to do. So x to the 75th times y to the 70th over x to the 25th, y to the 30th. Again, 1 term over 1 term, but multiple factors, 2 factors in each one. So the x's, can I do anything with that? Yep. I can do x to the 75 minus 25, and that's in the top, right? Because 75 is bigger than 25, that's the numerator. And then here, y to the 70 minus 30, and it's also where? In the top. And if nothing is left over in the bottom, there's really a 1 there, so we don't write it. So there's no fraction left. That's great. This one doesn't have a fraction. It's just going to be x to the, what is 75 minus 25? 50, and then y to the what? 70 minus 30 is 40. And if you'll notice my equals, this looks high here, but that's because I thought I might have something down here and I didn't. And that's okay, right? I was just making sure I didn't have anything down there. X to the 50th, y to the 40th. And then we have this one. So we have, again, 1 term over 1 term. It's a lot of stuff. It's got 4 factors, okay? My negative 20 is the first factor in the numerator. Then my p's, right? Then my third, fourth factors up here. And then the same thing in the denominator. I have the 60s, the first one, the p's, the v's, and the c's, right? So 4 factors in each one. So let's do the numbers first. Negative 20 over 60. Does 20 go into 60? Yep. So this is going to be negative 1 over what? 3. Okay? Negative 1 over 3. And then do the p's, right? Where are the p's left over? Well, 15 minus 3 is going to be in the numerator at the top, right? Because 15 is bigger than 3. What about v to the 10th over v to the 10th? Where's the bigger power of v? Oh, it's in the same place, isn't it? So if it's the same 10 and 10, how many v's are left over when we divide all those v's out? None, right? There's no v's left. No v's. And then c, 9's bigger in the bottom, the denominator, so it's going to be c to the 9 minus 2. So you see what I did here, right? I gave you a problem. I gave you a power bigger in the top, a power the same, and a power bigger in the bottom. You got to deal with all three of those things we talked about on the same problem here. Okay? So look, that's what math does all the time. Math builds. Starts with the really simple ones, right? The first ones I did maybe were just one thing, and it was one part of the property, and it was the easy part of the property. Then I gave you one thing, and then I added the second thing to it, and then a third thing. And here I've got 4 factors in each one, right? I got one of each scenario all happening here. So I don't like the way this looks here, so let me bring this 3 down a little bit with this, even with that C. All right, so then, those are ugly parentheses. I know I can't write. So this is going to be negative p to the 12th over 3c to the 7th. And again, one term over one term. What do we typically do with that negative sign? Negative, and I would have normally done that there, but I want to emphasize that. Negative and then p to the 12th over 3c to the 7th. Because it's one term over one term, just don't forget that negative and put it out front. Again, certain levels of algebra that I teach, I would give credit here. But once you get to college algebra stuff, I'd start saying, hey, wait a minute, let's go ahead and, we know that that's the case. Let's go ahead and take care of that. Let's take care of that. So then c to the 20th, d to the 7th over c to the 12th, d to the 30th. Again, this is very much like this one except c's and d's instead of x's and y's. So we take the c's. Where are the c's left over? In the top, the numerator. C to the 20 minus 12. And then where are the d's left over? The denominator, the bottom, right? Because 30 is bigger than 7. And again, it was one term over one term, right? That's why we did this. So c to the 20 minus 12 is c to the what? 20 minus 12 is 8. And then 30 minus 7 is d to the 23rd power. All right? So c to the 8th and d to the 23rd power. And then here, negative 25x to the 14th over 5x to the 27th. So here, again, it's one term over one term. So negative 25 over 5. Okay, 5 goes into both of them. So this is negative 5 and this is 1. And then where are the x's left over? In the bottom because 27 is bigger than 14. So x to the 27 minus 14 is going to end up being negative 5 over x to the what? 27 minus 14 is 13. And again, one term over one term. The reason I say this each time and emphasize this is I want you to learn to recognize this as you're working this, okay? Again, makes you better to pay attention to detail, all right? Which if you can just do that, you get better at math, all right? So just practice paying attention to detail. Negative and then 5 over x to the 13th. All right? And there is the final answer there, and that completes this video of dividing like bases.